Hello everyone and welcome to the NLP full course. In this video, we are going to explore the complete world of natural language processing from absolute basics to advanced concepts like BERT and Transformers. And also we'll study in a very structured and easy to understand way. So guys, have you ever wondered how chatbots reply instantly and how voice assistants understand your comments or how translation tools convert one language into another just in seconds? If you are interested in these technologies, then you will already be interacting with NLP every single day. But here's the interesting part. Behind every smart reply, every prediction, and every language model, there's a combination of text processing, statistical method, machine learning, and deep learning working together. In this tutorial, we'll start with the fundamentals, like for example, what NLP actually is and why it matters. Then we will break down core concepts like tokens, corpus, and text processing. And after that, we will move into practical techniques like tokenization, stemming, lemmatization, and vectorization. Here in this tutorial, we will also get a hands-on exposure using Python libraries like NLTK and SpaCy. And as we move ahead, we'll also progress into embeddings, language models, transformers, and BERT. So guys, watch this video till the end if you want to learn more about it. Now here's the agenda of our today's session. First, we're going to start with an introduction to NLP. Then we will deep dive into the fundamental concepts of NLP. After that, we will understand text processing techniques. Then we will explore NLP with Python and NLTK. After that, we will deep dive into SpaCy and advanced NLP libraries. After we have covered all of this, then we will deep dive into word embeddings and language models. And then we will explore transformers and BERT. And finally, we are going to wrap our session with NLP case studies. Now, here's a short quiz to test your knowledge. Which of the following is a primary goal of natural language processing? And your options are to increase computer hardware speed, or to enable machines to understand and process human language, or to design computer networks, or to create graphic user interfaces. Please mention your answers in the comment section below. Now, just a quick info, guys. Simplilearn has got Applied Generative AI Specialization course. You can learn to develop and deploy and also Gen AI-enabled applications in Applied AI course in collaboration with Michigan Engineering Profession Education and Azure. You'll also learn Applied Generative AI with hands-on training in agentic AI, LLMs, and tools like OpenAI, LangChain, and Stable Diffusion. You're going to learn from industry experts to drive innovation, automation, and business growth with real-world AI applications. So guys, hurry up now and join the course. The course link is mentioned in the description box. So let's get started. So guys, let us first try understanding what is NLP and why it matters. Now guys, if I talk about what exactly is NLP, then NLP is a branch of artificial intelligence that focuses on interaction between computers and human languages. Its primary goal is to enable machines to understand, interpret, and generate human language in a way that is both meaningful and useful. This process involves reading, deciphering, and understanding, and also making sense of human language in a valuable way. Now, you'd be wondering, why do we need NLP? See, NLP is very crucial because human language is inherently very complex. And also it is kind of nuanced, making it challenging for machines to process it effectively. Unlike programming languages, which are structured and formal, human languages have ambiguity, idioms, slang, and cultural context that makes interpretation difficult for machines. NLP seeks to bridge this gap and provide solutions that allow computers to process and understand language as we do. So guys, as we all know that NLP is actually revolutionizing the way machines interact with humans, and it is a key enabler of many modern technologies. If I talk about why NLP is so much important, because it improves communications between humans and machines, it allows machines to understand natural human language, which makes interaction with technology more intuitive. You can now talk to your phone, computer, or virtual assistant like you would do it with another person. For example, guys, the best example is voice assistant. For example, like Google Assistant, Siri, or Alexa, which understands spoken commands to respond intelligently to perform tasks like setting reminders, making calls, or giving directions. Also, guys, NLP enables automation of complex tasks. It helps automate processes that were traditionally done manually, such as customer support or content generation. For instance, guys, chatbots, which are powered by NLP, can handle customer queries 24 cross 7, and it reduces the need for human agents to answer simple, repetitive questions. For instance, guys, like if you go to the website like Zendesk and live chat answer, so you will find the customer queries are there, and these platforms answer the customer queries using NLP. It provides quick responses without human interactions. Now, one more important thing about NLP is this can also enhance the search engine functionality. How, guys? As NLP plays a very critical role in improving search engines by allowing them to understand better and process complex search queries. What it does is, guys, it helps search engine provide more relevant results, even if the search query is ambiguous or phrased in a conversational way. The best example what I could give you is Google's ability to understand. For example, if you ask, what is the best pizza in Bangalore near me? And it is going to return relevant results which is powered by advanced NLP techniques. Now also guys, if I would repeat, now also guys, if I would have to say, the next benefit which you can find is data-driven insights. NLP can extract meaning from vast amount of unstructured text data. It can be used to analyze customer reviews, social media posts, news articles, and much more to derive valuable insights for businesses and organizations. For example, guys, if you would remember the sentimental analysis, most of the companies do this. Now, the benefit of doing this is to track public opinion about their products or services by analyzing feedback to improve customer satisfaction. Also, guys, NLP enables automatic translation of text from one language to another, making it easier for people to communicate across linguistic barriers. So, machine translation tools like Google Translate or DeepL rely on NLP to provide a real-time translation between dozens of languages. The translation of text or speech between the languages such as English, Spanish, or French are powered by NLP technology. And they use models like Google Translate, which improves the translation of one language to the another. NLP also helps to create solutions that improves accessibility for people with disabilities also. Now this is pretty much interesting, guys. For example, like speech-to-text systems which allow people with hearing impairments to interact with digital content, while text-to-speech system assist people with visual impairments. For example, the voice-activated controls on smartphones and real-time transcription of spoken language into text improves accessibility for people with disabilities. And this paves the way for AI-mediated communication. As NLP models evolve, they are enabling more intelligent and nuanced interaction between humans and AI systems. And this paves the way for AI-driven assistants which are capable of deeper understanding, emotional intelligence, and decision-making capability. The best example which I could give you guys are the tools, for example, like Grammarly or Copy.ai. Let me open it for you. These technologies utilize NLP to help you with writing, checking grammar, generating content and ideas, and offering improvements. Now, you'll be wondering, how can I learn this technology? That's pretty interesting, guys. So you can learn by understanding some of the key components which are involved all over here. Let me explain you the key components which are present in NLP. So guys, the key components that involve all over here are, the first is tokenization. Okay, now if I talk about tokenization, guys, it is a process of breaking text into smaller units of words, sentences, or subwords. Then you have something called as part of speech. Now, what is this technology, guys? Basically, with the help of this, you can identify the grammatical components of a sentence. For example, like noun, verb, or adjective. Then you have something like as, we call it as named entity recognition. Now, what is NER technology? Basically, this identifies entities like names, dates, or locations in a text. Then you have something called as sentiment analysis. So this is also pretty interesting, guys. Okay. Now, if I talk about sentimental analysis, it determines the sentiment or emotion which is expressed in a piece of text. Then you have something called as text classification. Now, you will also need to categorize the text into predefined categories. So, what are those predefined categories? So, like it could be the spam detection, topic categorization, or intent classification. Next, you have something called as machine translation. So, what does basically a machine translation do? Basically, it translates the text from one language to the another automatically. So, in nutshell, if I have to say, guys, NLP is the backbone of the modern AI-driven application, and it relies on the underlying technology. For example, you can see in the architecture, you have the entity recognition, you have the information extraction, summarization, translation. It checks for spelling and grammar. You have the text classification. You have the emotion detection. Then these are the annotators. Then you see the models that are pre-trained models basically, or transformers you can call them, for example like BERT, XLNet, Glove. Okay, and then all the languages data are set all over here, and it supports somewhat say 200 plus language. Basically this is on Azure. So this technology which is made for doing the NLP task, like understanding your context. So these are the respective things what basically is present in NLP. Now, also guys, if I would say, there are many applications of NLP that we use every day. Its applications span across various fields. It could be from virtual assistant to healthcares, and also guys, its growth is accelerating as this technology is improving. Now, let me give you a brief overview about where are we using NLP today. So first of all, I would say in chatbots and virtual assistant. Everyone in today's scenario are using this. So what is this exactly? Basically, these are the AI-powered conversational agents that can simulate a human conversation. For examples, the chatbots which are using NLP to interpret and respond to user queries in a natural language. Now, what do they do basically? They are used in customer support, sales, and marketing to handle routine inquiries without any human intervention. For example, if I would say, let's take an example of customer service. So many companies like banks, e-commerce sites, and tech support use chatbots to answer frequently asked questions or to process simple requests, for example, like password resets or prompting direct to users to appropriate resources. Then let's take another example of support channels. Their chatbots are available in popular messaging platforms such as you will find it on Meta or WhatsApp. Now, this is actually very much helpful because they are helping customers directly in their apps. And if you could look the virtual assistant, which are already present, whether it's on your iPhone, like for example Siri, or on Amazon products, you will find Alexa or the Google Assistants. So all are examples of virtual assistants which are powered by NLP. What do they do, guys? These systems basically understand and process user commands given in natural language, and it perform tasks like setting reminders, checking weather forecast, controlling smartphone devices, and playing music. Now, you would wonder how does it works? Basically, virtual assistant use voice recognition and NLP to process the spoken input. NLP helps understand intent, retrieve information from web, or perform an action like sending a text message or turning on a device. Then you have something called as search engine and information retrieval. So if you look on the Google search, when you type a query into the Google, it doesn't search for exact keywords, but it also tries to understand the context of your question. Now, what Google is using is NLP technology, basically to interpret search queries and providing results that are not just keyword matched, but contextually relevant. Google's ability to answer complex queries like, for example, what's weather in the Paris tomorrow, or who won the Super Bowl of 2026, So these things are actually driven by advanced NLP technique, and that basically helps you to understand both the structure and intent behind the query. Then you have something called as search engine optimization. Now, NLP is also using the SEO to understand how search engines interpret content inside the web. So what does this do, guys? This basically helps businesses optimize their content and keywords so that it ranks in the search results. Then you have something called as machine translation. So Google Translate is one of the very amazing technology, guys, and which is powered by NLP. And it also uses some other machine translation services, which allows them to convert text from one language to the another. And the translation is based on learning from vast bilingual corpora, which is a large data sets of peer translation. For example, guys, Google's translates ability to understand both literal and idiomatic expressions accurately is a result of NLP algorithms, which basically leverage deep learning models like BERT, which stands for bidirectional encoder representations from transformers. It uses something called as text sentiment analysis, basically where you have social media monitoring. So here, sentiment analysis tool uses NLP to analyze user-generated content on social media platforms to gauge public opinion or any brand sentiment or any customer feedback. Let me give you a very clear example of this. These days, companies are using sentiment analysis to track how people feel about their products. Let's say someone wrote the review about certain product. So these products basically analyze the reviews. Or you can also take example about the tweets on the Twitter or posts on the Facebook. It helps the team to adjust the marketing strategies and improve customer service or also launch any targeted campaign. Now, if you could also look about the another thing, if you could remember this application called as Book My Show. So here you would find movie reviews and feedback. Now, this is the best example of sentiment analysis. So here you can monitor customer feedback about products or services. NLP models which are used in these platforms can classify reviews, whether these are positive, negative, or neutral, providing actionable insights for businesses to improve their offerings. So this is in terms of movie business or ticketing businesses, basically. Now we have one more interesting thing that is called as healthcare and medical NLP. And this is called as electronic health records. So if I talk about EHR, NLP is used in these areas to extract insights from unstructured data in medical records. So doctors' notes or patient histories or lab results, so they analyze these data. And with the help of these data, these models automate medical documentation and it makes information retrieval more efficient. So for example, guys, NLP can help in analyzing large data sets of patient records to identify patterns, predict diseases, and even assist in clinical decision making by providing insights into patients' conditions or treatments. One of the amazing technology which uses the NLP is Sophos. So what do Sophos do? Basically, this is a fraud detection and security app which basically does the email filtering for you. So what basically is happening all over here? So NLP here is used to classify emails into spam and non-spam categories. So these uses the email clients like Gmail and and after that they use NLP models to detect spam and phishing email based on the patterns in the content, such as the presence of certain keywords or any suspicious language. Now, this is a cloud security solution, and they have much more thing going on. They have advanced solution for these kind of fraud detection activities and covering some of the very important edge cases. So guys, these were some of the amazing NLP use cases, and these were some of the real world examples, and you would find out how NLP is turning a very important technology in our today's scenario. Now guys, let us discuss a bit about history and evolution of NLP. So guys, NLP has come a long way from its humble beginnings and has seen major developments over time. So let me give you a brief overview about the same. In the 1950s, the first was the given time when the foundation of NLP can be traced back. And everyone knows about this great scientist, Alan Turing, who actually in the 1950s proposed the idea of a machine's ability to think or exhibit intelligence. And he proposed a test that we call it as Turing test, basically which sought to measure a machine's ability to exhibit human-like behavior. And it laid the groundwork for later NLP research. Then, in the 1950s and the 60s, you got early rule-based systems. So researchers began working on basic rule-based systems that could perform simple tasks like machine translation. And if I remember exactly, it's the Georgetown IBM experiment which happened in 1954. And it is often cited as the first major machine translation project, where a computer translated Russian to English using predefined linguistic rules. Then we saw an era of 1980s to 1990s, and we call it as the statistical NLP. Now here, there was a kind of a shift to statistical models. So in the 1980s to 90s, the focus of NLP research kind of shifted towards statistic method. Now, what did they do, guys? Basically, they have used probabilistic models to analyze and interpret text data rather than relying on predefined rules. And these models learned patterns from large corpora, or we call it as data sets of text. Then also, guys, there was a technology we call repeat. Also, there is a very important discussion about the Markov models, or we call it as hidden Markov models. HMM actually became popular in speech recognition and part of speech tagging task. What did they do, guys? Basically, they allowed systems to model sequences of word or sounds that were a major advancement over rule-based systems, which were actually happening in the 50s and the 60s. Then finally came the corpus-based methods. Okay, so after the HMM era, we got this respective thing. Now, what did it do, guys? Basically, it led to creation of large data set of text, such as the Brown corpus in the 1960s, and you could also find the Penn tree bank data in the 1990s. So these were very large data sets, and it amounted to the linguistic data, and it was set to train statistical models, leading to more accurate language processing. Then you had something called as machine learning and deep learning era, which is basically happening since 2000 and present. And with the machine learning approaches, and we saw a major advancement in NLP. So now there was a kind of improvement in accuracy. So if you could look into algorithms like support vector machines and naive Bayes, it became popular for tasks like text classification and sentiment analysis. Now, later on the year, in 2013, you could also see the deep learning also actually kind of became very much popular. And deep learning is a very interesting technology. It just goes way beyond machine learning. Now, when researchers were actually studying or creating the deep learning techniques, so with the help of the algorithms, what were written earlier, NLP's accuracy was improved very much. And this led to a development of models like word embeddings or recurrent neural networks. So these models could capture complex relationship between words and understand the context of sentences, leading to much more powerful language models. Also, later in the years, you would also find out transformer and attention mechanism. So people started introducing the transformer model and marked a very big breakthrough in NLP. The transformer architecture, particularly its attention mechanism, allowed models to efficiently process sequences of text in parallel rather than sequentially. And till now, because of these improvements, NLP is growing in a direction where you could not imagine. It is getting intelligent day by day, the models are improving, and you could do tasks like machine translation, summarization, question answering very much effectively. Also, if you look on the pre-trained models like BERT or GPT, this was the next milestone that came. And all over here, what we saw was that these models are actually using large scale pertaining on vast corpora of text data. And also, guys, it follows fine tuning for specific task. So if you look at the models like GPT-3 and BERT have achieved the state of art results in variety of NLP tasks. Now, guys, if you look at the models like GPT-3 and BERT, they have achieved the state of art results in variety of NLP tasks, such as question answering, sentiment analysis, language generation. So these are some of the core things that you can look about this. Now let's look at, now in today's scenario, we have something called as multimodal NLP. So recent developments in NLP are focusing on integrating text, images, and also audio, and it uses models like Clip, DALI from OpenAI that are bridging the gap and the vision and also the language of the textual confirmation. Repeat. So guys, these models are bridging the gap between vision and language by understanding both the visual and the textual transformation. And finally, I would say it has actually amazing use case in ethics and bias NLP. So guys, if you look on the latest GPT model, which is GPT-5, and if you share any image to GPT, it actually reads all the text from the image. Now, this is pretty interesting and one of the most amazing aspect of using NLP. And finally, if I talk about ethics and bias in NLP, so models have become very much widely used, and issues which are related to bias and fairness are receiving increased attention. And this ensures that models are ethically developed and they do not reinforce any harmful stereotypes in an ongoing field. And this is kind of a big challenge in this field. And the kind of algorithms we are developing, there is a growing interest in the real-time NLP, where systems can interpret and respond to user inputs almost instantly. And that's what our current technology is trying to do. So in a nutshell, that was the history and the evolution of NLP. Now let us move ahead to the next part where we are going to explore some of the interesting things. Now guys, let us explore some of the fundamental concepts of NLP, and after that we are going to use Google Colab for our hands-on thing. So first of all, let us understand some of the key terms and terminologies. So first of all, let's discuss a bit about, you can say, what are tokens, corpus, and how the text processing actually happens. So let us first discuss a bit about tokens, guys. Now, what are tokens? Basically, if I would have to say, a token is a unit of text that represents a meaningful piece of data. It could be a word or a punctuation mark also. Now, tokenization is a process of splitting text into these smaller manageable units. Let me give you one great example. For example, guys, let's consider, let's say we have this respective text, and if someone says, "How are you?" Now, in this, what are the probable tokens? So, if I would have to make tokens in this, so the tokens would be, for example, it could be hello all over here, and it could be, for example, an empty string also, if there are any empty spaces. For example, like if I give something like space like this, so I can also make an empty string as our respective set of tokens. It could be also, for example, like how. Next, it could be like are. So I hope so you are getting a brief idea of what I'm trying to say. Similarly, all over here, you could also find this thing. So these are our respective tokens. And the process of splitting this text into these respective tokens, we call it as tokenization. And also, guys, this actually helps machines analyze each part of the sentence independently. Let me tell you one real world example. Now, let's say, guys, in your phone, you are using a chatbot like Google Assistant. And when you say set a reminder to call mom at 3 p.m., the system first tokenizes your voice input. Then the tokens help the AI to understand the words and the action you want. For example, like setting a reminder or calling someone. And this is the time related information. And finally, when the 3 p.m. comes, a call is dialed from your phone to your mom. Now, this is pretty interesting application of tokenization. Now, let me tell you something about another interesting concept that is called as corpus. Now, corpus is actually a large structured collection of text that is used to train NLP models. A corpus can consist of books, news, articles, websites, or any form of written content. And the quality and the size of the corpus significantly affect the performance of NLP algorithm. Let me tell you one good example. For example, like the uh, crawling data set, if you could see, this contains repeat. Now, guys, this is a common crawl data set. Basically, it contains petabytes of web data, and it is commonly used as a corpus in NLP research. Now, this data helps model to learn diverse language patterns and structures across various domains. One good example could be a Google search. Let's say when you try to search for something on Google, the search engine uses large corpora to understand the intent behind your query and fetch the most relevant results. Now, if you would remember the Google's BERT model, for instance, it was trained using huge amount of text from the internet, basically the corpus data, to understand and the nuances of languages in the search queries. Now let us try to understand the third important concept that we have, and we call it as text processing. Now, text processing refers to the series of steps which are involved in cleaning, preparing, and transforming raw data into a format that can be analyzed by NLP algorithms. This includes tasks like tokenization, removal of, let's say, stop words, or lemmatization and stemming. So these are the things which we are going to discuss in the near future. So we'll just note it down here. The techniques, for example, like tokenization, or you'd find something like removal of stop words, or you can think about this technology, lemmatization. And finally, now, what are the key steps that happen in text processing basically? So let's say stop word removal. Let's say, for example, if you want to remove common words that don't add any meaning, like for example, the is an and. So those are called as removal of stop words. Now, if I talk about repeat, this is called as lemmatization. Then you have something called as stemming. And if I just call about stemming, it's a very interesting technology. It just means like trimming words to their basic forms, and it often leads to incomplete forms. For example, like running becomes run. One good example would be like sentimental analysis. Let's say if you're trying to do the sentiment analysis in Twitter, and let's say your system scans a tweet to analyze the public opinion about any product, or let's say any political opinion. What it does first, it processes a text to remove the stop words, for example, like and the. Then it performs a tokenization. Then it lemmatizes or stems words to ensure informity. For example, let's say all over here, if I write something like this, that love stays, okay, as is, while loved and loving get reduced to love. And you can call it loved and loving will be reduced to love. So this is very interesting part of our text processing process, and this happens across all over here. Now, this processing actually allows the system to better understand the overall sentiment. I hope so, guys, you would have got a brief idea regarding this. Now, I would also want to discuss a bit about, let's say, types of text data, because without understanding that, you would not start the processing of that. And the types of data, if I just had to say, so these can be configured into structured or unstructured. So there are two forms of this. So what is a structured data, guys? Structured data is highly organized, and it is typically stored in database or spreadsheet where each piece of data fits into the specific field. So structured data is easy to process and analyze because it's neatly arranged into rows and columns. Now, one good example I would like to share with you. Let's say we have a customer feedback form. So let's say I have the fields like name, email, rating, and comments. So all the data which I'm trying to fill all over here would be neatly structured. And here data can be easily processed and analyzed using algorithms that look for trends or patterns in the ratings. For example, if I talk about the customer relationship management, so in Salesforce, customer data is organized in structured format. And each customer's interactions, for example, like it could be purchase history, preferences, are stored in those respective fields. And this makes it easy for sales team to retrieve insights about customer behavior or generate reports. Next up, what I could talk about is the unstructured text data. Now, this is kind of a bit opposite to what we have discussed. So, on the other hand, this data is not organized in a predefined way. It can be in the form of free text like emails, social media posts, or open-ended survey responses. And analyzing unstructured data is more challenging and requires uh, NLP techniques to actually extract meaningful insights. Now, Twitter is a classic example of unstructured data, guys. The post, the tweets, if you see, it contains text, emojis, hashtag, and sometimes even images or link. Now, if you're trying to understand those things, it requires NLP to extract the meaning. So, tools like Brandwatch or Sprinkler, basically, these tools analyze tweets and posts to gauge sentiment and track the brand mentions and detect emerging trends in the real time. I will show you those tools, guys. So you can look for something like this is called as Brandwatch. So this is an amazing tool, social insight tool, basically built on the NLP technique. Or you can also use Sprinkler all over here. So this is also an amazing tool which is built on the same NLP fundamental principle, what we are trying to discuss. So these are the particular case studies of NLP, guys, and that's pretty interesting how someone made a use case into a proper working company. Now let us move forward and try to actually look for something pretty interesting discussion that I would say how NLP you can compare with the traditional techniques. So if I talk about the traditional text analytics, so this typically involves manual or rule-based methods where you have predefined rules, dictionaries, or regular expressions which are used to identify patterns in a text. It is kind of less flexible and doesn't learn from the data. For example, one good thing about traditional text analytics, if you could find out, is keyword matching. Let's say if you are trying to look for a specific word or phrase in a text. So traditional analytics would easily do that task, like matching the exact thing. Or if you're trying to manually do the categorization, like assigning topics or categories to the content based on predefined keywords, so you're going to use that. And early search engines, like if you would remember Alta Vista or Yahoo, basically use traditional methods like keyword matching. And if you search for, let's say, best pizza, the search engine would typically find pages that has exact phrase. Now, NLP is a modern technique and it's a modern approach. And in contrast to a traditional analytics, it utilizes machine learning and deep learning algorithms that can process text and learn from data. It can also handle more complex tasks like understanding the meaning behind words, recognizing sentiments, and generating human-like text. And its example would be contextual understanding. So models like GPT can easily understand the context of word in a sentence, even if the word has multiple meanings. One good example I would like to tell you, let's say bark. So bark could also refer to outer covering of a tree and sound what a dog makes. NLP can differentiate the two meanings based on the surrounding word. Imagine this as a complete ambiguity, but we are actually working around all over here. and with GPT, and everyone is using GPT every day, and you could find out how this technology is trying to use the meaning around the surrounding words. That's pretty interesting. And one interesting model also I would like to discuss a bit about is Google's BERT model. Now, BERT model actually revolutionized how search engines process queries rather than just looking for exact keywords. It can now understand the intent behind a user search even if the query is conversational. For example, like if someone asks you how to make pizza with no cheese, now Bird is going to easily understand that if you ask to it, and it could exclude cheese even through though the query does not contain the word cheese free. Okay, so these are kind of very much important things to discuss. And in nutshell, I would say tokens are like the building blocks of NLP. It breaks down the text into manageable parts like words and punctuation, and uh, that's a kind of a pretty important thing. Without which NLP won't be able to proceed. And these fundamental concepts actually forms the core idea behind NLP. Now let's deep dive into some of the hands-on things such that we have a very clear idea. Now guys, for this hands-on activity, we'll be using Google Colab. So just type Google Colab guys, and the first link is the Google Colabs. So you can open it all over here. Now after this, you can create your own notebook. Okay, just click on new notebook. Let us wait for a couple of time. Okay, so you can see this is our given notebook. You can change the name all over here to NLP. Okay, now there's an interesting thing. If you would notice, the files extension which are stored on Google Colab are of type IPNB, now which is kind of pretty much different from the normal Python files. Well, this was it about it. Now let us try to perform tokenization, stemming, and lemmatization. So I've already told you about tokenization, that it's a process of splitting text into individual words or sentences. So it's one of the first steps in NLP. Now, in order to do this, first of all, what you need to do is you need to import NLTK and all over here. But before starting that, let us install NLTK library. So just go all over here. This is the official website of NLTK, and this is a natural language toolkit. So we'll be using this library of Python, and all you can do all over here. This is a very amazing library, and if you want to use this library, just import NLTK. Okay, and let us say all over here that we have respective thing. Let's say import NLTK, and let's try to run it. So you can see it's connecting to the server. Now it's pretty fine. My charger is inside. Can you no, add it over there? No. Now after this, guys, what you need to do is, let's create a variable called sentence, and let's say it says at 8 o'clock on the Thursday morning, Arthur didn't feel good. So we'll just copy this line and we'll just create a variable all over here. So guys, let's copy this all over here, and now you can see all over here. Let's create another web variable named tokens, and let's use this given function tokenize. So let's add it up all over here, and this means that we are using normal token as a variable, and we are using NLTK library, and there's a function called world tokenize function which is coming from this respective library, and we are trying to tokenize this respective sentence. So all the internal things, like how the process of separating this into tokens, all this internal things has already been taken care by this respective function. Okay, so you don't have to worry about that. Now next part, let's try to do this. So now guys, after that, I will just try to print tokens all over here, and then we'll do the part of speech tagging all over here. So NLTK.POS tag. So this is a respective function where I'm passing these variable token, and finally I'm trying to the respective words from all over here. But before that, I am downloading the punct. Now guys, the issue was all over here. So based on our respective error, we didn't have the punct app. So I downloaded it, and this was average perceptron tagger English. So based on finding the perception about each word in a given sentence, basically supporting English one. So we had to download this before we started processing any task. Now you can see started downloading the respective package, and you can see the tokens have been generated, like we are getting at 8 o'clock on Thursday morning, and these are the tag words at in 8 o'clock on in Thursday, NNP morning, all those things. Now you could see all over here I have added this slicing all over here. So I want it to be sliced into 6 parts, and you can see we have got the 6 part 1, part 2, part 3, part 4, part 5, and part 6. So this was the first step about tokenization, guys. I hope so you would have got a brief idea like how we have tokenized this sentence. Now the only thing that was missing was we didn't download the punct, and after that we had to download the punct app, and similarly we had to download the perceptron tagger for English language. So these were a couple of things that were missing. Now I hope so you have got the idea. Now let us move to the next part. Now guys, let us perform another operation that we call it as stemming. So guys, if I talk about stemming is a process of reducing words from their root form. Now this might not be repeat. Now this not might be always a valid word. So that's what we discussed earlier. Now let us try to do the same thing all over here with the stemming. So we are going to import repeat. Now guys, for the same purpose, we are going to use NLP library. So let us say from NLTK, and here what I could do is I could use .stem. Now I have to install repeat. Now guys, as you can see, Collab is already supporting this thing. So we will import the porter stemmer. So just click on to the tab, and you can see, but this will help us to perform the stemming process. Now this at the next step, what we are trying to do all over here is we are trying to initialize our stemmer. So let me write all over here, initializing stemmer. Now after this, let's say let us try to create one variable. Let's say we can call it as words, where I could easily create it in a list. So let's say for example we have words all over here, and let's say the words could be all those things. Let's say it's eating, eats, ate, adjustable, rafting, ability, meeting, all those things. And after those things, what I could do is I could create this variable stems all over here, and I could use the respective stemmer that we have initialized. So this equals to, let's say, stemmer. Okay. So stemmer.stem, and we could use the variable words, and then we use the for loop all over here. Now this is kind of a list comprehension what I'm using. So if you're not aware about list comprehension, let me tell you. So this is inside the list, this is called the given condition. If in this given stemmer function, you need to use the stem function, okay, and use the word variable all over here, and then you loop for the respective words to find the respective reduced words all over here in this list. So this is kind of a given thing, and you are creating a new variable all over here. Now for doing this, you are using the stem function, which is coming from the respective this library, which we call it as the NLTK.stem library. Okay, and let us try to run the respective thing and see what we are trying to get. So you can see we are getting that eating is adjustable has reduced to adjust, rafting is reduced to raft, ability is reduced to able, meeting is reduced to meet. Now we will try to perform one more thing that we call it as lemmatization. Now people often get confused between lemmatization and stemming. I would say that lemmatization is similar to stemming, but it is kind of bit more advanced. It returns a valid word by considering the context and the dictionary. So what we can do, guys, for the hands-on purpose, we can use NLTKs WordNet lemmatization. And for doing this, what I would use is you use the same thing. So from NLTK.stem, let's write this. So all over here, NLTK.stem, and after this, we call it import, and you can see it has already given word lemmatizer all over here, and then we initialize our respective lemmatization. Now, after this step, I would also need to download the respective WordNet. Let's just call NLTK download, and all over here you need to give WordNet. Now, after this thing, what you need to do is you need to use the respective repeat. Now, after this, guys, we will create a list. So let's call it as words, and all over here, let's say our respective words has these things. So let's say it has something called as eating. The same thing, eating aids adjustable rafting ability and meeting. Okay. Now, let's create one more variable. We can call it as lemmas, and we can call our lemmatizer all over here. Let's assign this to lemmatizer, and you can see we can use the same concept all over here as a list comprehension. So this could be done all over here, and what we could do is this could be equals to lemmatizer. We can use the given function, which is lemmatize. So in the lemmatize function, we will use the word all over here, and then we use the for loop such that we are trying to lemmatize each of the elements which are present in this respective list. And finally, then I'm printing the lemmas. Now, also, what else I could do is I could change the respective thing, and I could also give one more variable all over here. And let's say here I just give something like, let's say the POS, the position is equals to, let's call it as V. Okay, all over here. Now after this, we are trying to do the lemmatizing. Now let's say if I want, what basically I wanted to do is I wanted to lemmatize the verbs basically, and then let's print the lemmas. Now let's run this and see what we are getting. So you can see we are lemmatized these respective words. Now I have already told you earlier that but it is kind of similar to stemming what we discussed, but it is kind of a bit more advanced. It is actually returning a valid word. Now in the earlier example, you would see ability was returned as able, but if you're using lemmatizer, what you are getting is ability exitus. So that's a kind of pretty interesting thing to see all over here. Now let's try to see one more important concept. That's call it as stop word removal, or basically the POS tagging, part of speech tagging technique. Now, if I look at the stop words, these are the common words like the, is, on, which are often removed to focus on meaningful words. So for this, we are going to use corpus, and we will import the stop words. So let us try to start from here, from let's say NLTK, and let's say I'm using all over here corpus, and let's say import, for example, your respective stop words, and then you need to download the stop words all over here. After that, guys, what you need to do is you have to give a sample text. Now in the sample text, what I could do is I could let's say create a variable all over here, and let's call it as stop words, and we can use a set function all over here, and inside the step function we can call set stop words. The words are English. Okay. Now after this, we'll set up the respective text. Let's say very easy text. We can just put it up. For example, like the cat sat on the mat. Okay. And then let's create another variable. We call it as tokens, and we will call this function words dot tokenize. So this equals to, let's say, NLTK.word.tokenize the respective given text. And if after this, we have to perform this very important operation that's called as removing the stop words. So let us create another variable for the same. Let's first do the comment. Let's say removing stop words. And after this, let's say we just create a variable, we call it as filtered sentence, and the same list comprehension that we are using, let's say W for in W, if not in W, in stop words basically. So what does this line means? First of all, W is a given expression, so we need to find for the W variable. So, and W is a kind of a stop word basically. So for in this respective tokens, whatever we are having, okay, if W is not there in the stop words, you need to return W. Okay, so we need to return those words in the respective tokens who are not part of the stop words. Okay, so stop words means the it could be in and all those respective things. So this is your filtered sentence. We are not adding those things. So let's say if I try to now print filtered sentence, so let's copy this and just paste it all over here. Now let's try to run this and let's see what is our respective output. You can see it has started processing. Now you can see the output that I'm getting is, so the thing was it's kind of a case sensitive. Okay, now you'll be wondering, like, if T is capital, then there are some other techniques to deal with that, but if you're using uh, this technique with this respective function word dot tokenize, it could not differentiate between the uppercase and the lowercase. So that was one of the example of tokenization using part of speech tagging. Now third, we will discuss a bit about vectorization. Vectorization is a technique in which you try to understand word as a bag of words and consider it as an individual unit. And all the words are presented as vector. There is one technique, we call it as bag of words, and also TF-IDF technique. Now, what is this bag of words model? Basically, this represents text as data, as a set of words without considering grammar or word order. So guys, let me show you how I can implement count vectorizer using scikit-learn library, and I will show you how we can implement bag of words technique. Now guys, let us install scikit-learn. So we'll type pip install scikit-learn, and we have done this. Now it's time for us to repeat. Let's say after this, I install all over here. Let's say I love coding, and let's say I can also add one more string all over here. Let's say I love machine learning. Okay, and let's initialize our vectorizer. So let's say this variable is vectorizer. This will be initialized using count x vectorizer function. So now guys, let me try to run this program and show you what exactly these techniques revolve around. So guys, it might take some time. Let's say it's installing the scikit-learn all over here. And you can see we are getting the respective vectors all over here, which is coding, learning, love, and machine. Now it's showing the analogy in form of the binary matrix representation, or you can call it as a sublist also, but it's calling it 1, 0, 1, 0. So you can see what are the emotional words that's giving some sensation or sensitivity. Those have been marked as 1, 1 all over here. And also this given method is showing the words which are present in the vocabulary. It's not showing I. Okay, it's also not showing the repeated words also. So learning, coding, love, machine, these are the respective bag of words which has the vocabulary meaning and which it's trying to show all from here. This is pretty interesting, guys. Okay, now let's try to understand another technique that is called as term frequency and inverse document frequency, or IDF. TF-IDF is used to evaluate the importance of a word in a document relative to the corpus or a data set. It's considered better than bag of words technique because it appears across multiple documents. So guys, we are going to use scikit-learn to demonstrate the same, but instead of initializing a normal vectorizer, we are going to initialize the TF-IDF. Now guys, if you see all over here, then I have done the same thing, but the only initialization factor here is changing, that is TF IDF vectorizer. Now using the same method, get features name out, then I'm printing it to array all over here. Let's try to run this and let's see what is our respective output. Now guys, let's try to run this. Okay. Now you can see the relative matrix which is given, the values are pretty much accurate as comparison to these words, what we are getting. And this has a very important significance on, let's say, the list of the words which are present in the documents. And 0 is represented which are not being considered into the relative meaning. That's pretty interesting. So if we compare bag of words and TF-IDF, I would say TF-IDF has a broader explanation. Now let us try the same thing with understanding the emojis. Now guys, let us take another edge case where we deal with various other things like punctuation, white spaces, emojis, and numbers. So what are punctuations? First of all, that's very kind of basic thing, that punctuation marks repeat. Now, you'd be wondering, why do we delete punctuation marks? Because they are often removed during pre-processing tasks, as they do not contribute any much more meaningful information, even as compared to emojis and the white spaces. And for that, I have one example for you how you can process those respective things. Let's say I have this respective text, hello, how are you? And in this given respective text, I want it to do the processing of this using no punctuation. So for the same purpose, I'll use a join method all over here. And this is a list comprehension, which is understanding each of the characters present in this. So for char, if it's not in the text, and it's also it's not there in this respective thing, then print text no punctuation. So ultimately what you are trying to process all over here, you are with the help of join method, you are trying to remove all the punctuations which are present all over here in your respective sentence. For example, if you consider this question mark, the same thing all over here. And this is the respective condition, and this is called as list comprehension. If you feel any problem with the Python syntax and what's trying to do, please refer to the official documentation, or you can look at the Python tutorial on our respective channel. Then similarly, let's say we have another text. Let's say this is hello world, and let's say here there is an emoji. So how you are going to process this? So let's declare another variable called text clean, and we remove the extra white spaces using this. But no emoji is being done all over here. So this is the split method, which is actually helping you to remove the all the white spaces. And let's not take this as one of the given text example. Let me show you another one. Okay guys, now if you could see in this respective text, it's written I love coding, and there is one emoji present all over here. Now how do you process this respective thing? So you use the emoji library which is present in Python, and you call the replace emoji function, and you just put the respective function all repeat. You put the respective text all over here, and then in the replace thing, you just add empty strings, and then it prints no emojis. So these are some of the text processing techniques when you have to deal with, let's say, string, let's say if you want to remove white spaces, or even if you are dealing with the emoji. I hope so guys, you would have got a brief idea regarding the same. Now let's move ahead to the next part. Now guys, let us start with the respective hands-on. So let us first install it. So don't add this. So guys, just type this command pep install -u and then add SpaCy. And after that, what you need to do is all over here, then you need to actually load this respective thing. So let us create one variable all over here. Okay, and let's assign this to c.load. And after loading this respective thing, okay, so this is kind of a very much important thing. So we are actually loading the pre-trained model. Okay, now let us assign a variable all over here. So let's first correct this. Okay, we have not imported it, that's why it's showing error. Now you can see it is resolved. Now let's assign this variable. Let's call it as text, and let's say that, for example, SpaCy is a powerful library, and let's keep it that way. And after that, what you need to do is, guys, let's create another variable all over here. So we need to process the text using SpaCy's library. So let's create another variable and let's call it as doc, and we use the same variable all over here and pass this variable which is equal to the respective string all over here. Now what we are doing next is we are going for the for loop. So for ent in docs.ent, so this is basically where we are printing word and its POS tag basically. So you can also go with all over here. So let me change this to something like for token, and after that we can use this for token in doc. We're printing the token, and then after that we can do the respective POS tagging all over here. So what we can just use this all over here is this. Let's add something also. Let's say we can add it up. Let's say respectively call it as word, and here we can add, okay, and this we can keep it up. Okay. Now after doing this, guys, we could give the respective POS tag. So what we can do is we can just write, let's say this is POS tag. So we can call POS, and we could give something called as tag. Then we could write the respective thing, and we could add POS all over here. Don't add this row. Now guys, this code is completed, and as you can see all over here, first we are loading the pre-trained SpaCy model, okay, all over here. Then let's say there is a sample text. Let's say Apple Inc. is planning to open a new store in New York on January 1, 2022. Then we process the text all over here, and we use this respective variable that we have declared, and inside this we pass one argument text, which is this respective string all over here, and then we extract and print all the named entities, where I'm printing the entity text and entity label. Let me run it for you guys, and you can see it has started running. Let's just wait for a couple of time. You can see this is all the named entities. It is extracting all the important thing all over here. So this is a very amazing technique, guys. You can use it all over here. So that's pretty interesting. Now let us move to the next part, where what we are going to do is we are going to do the dependency parsing, and we are going to print a word and its syntactic relation all over here. So what we can do, guys, so this is a part of speech tagging, okay. So if you want to do with the space, so I've already told you SpaCy is kind of an advanced library all over here, and you can see there's example text that SpaCy is very powerful for the NL respective task, and you can see sample string I have added all over here. Then I'm doing the POS tagging. So this is a for loop iteration. I'm just trying to extract this respective text, passing under all over here, then its respective tag. And then here you can see I'm doing the dependency parsing. I'm printing the word and its syntactic relation. So first text, then token head.text and its respective dependency. Now let me run it and show it to you how it is being done. So you can see all over here. So you can see the word is, the POS tag is aux, word A, POS tag is dead. Then you have the respective POS tag ADJ. Then you have this is noun, pronoun, and all these respective thing is being given by this respective library. So it's pretty interesting for if you want to do the text processing. Now let me explain you. If you look at this part of the line where I'm saying token.pos. So what is this, guys? This is an access. Repeat. So basically this accesses the part of speech tag for each token. For instance, it will classify word as noun, verb, or adjective. Then you could find out token head.text. So this is actually providing the head of the token, the word that governs the syntactic relationship. And then you have token.dep. So this is returning the syntactic dependency relationship between token and its head, means the subject and the for example, like the subject and the object, and you get the respected output all over here. For example, you get the PX tags as aux and PX tag as det, and then you get adjective, noun, pronoun, and all those things. So that's kind of very much important with respect to this. Now, guys, when I talk about POS tagging, it helps identify the grammatical role of each words, and dependency parsing shows how words are connected in terms of grammatical relationship. Now, if you look at these text classification, it involves assigning categories or labels to a piece of text, such as classifying a product review as positive or negative. And SpaCy is a text classification. Will classify and review as positive and negative using a pre-trained model. And for simplicity, we'll assume binary classification means it is either positive or negative. And we'll use a simple data set. Now let's use the same thing. Let's delete it all over here. Okay. Now, first of all, we install it, then we import it, which we have already done. And we'll be using this pre-trained SpaCy model for this demonstration. Now let's create a text all over here. So let's create a variable first. So let's call it as review, and we could give it as something. I love this product and it's amazing. And then I pass a respective thing under this model that we have loaded through SpaCy. Now it's time to process the text. Okay, so this part is basically called as text processing, and we are assuming a custom classification all over here. This pipeline here will display the prediction, and this would need training on a data set, and here we will demonstrate processing. So what we can do, guys, all over here, we can do this respective thing, and let's print it. So just pass this respective variable, which is review. Okay. Now we can print the sentiment. What is the respective sentiment all over here? So let's say if you want to print that, say print, and let's say if this is a respective thing. Okay, and let's just say that the respective sentiment that I'm having, it could be positive. Okay, so and we could just give all over here this as, let's say, positive. So when I do this thing, let me just first explain you what I'm trying to do. So when I pass this given text into this model, so what is happening is reviewing and processing the input text and applies these pipelines such as tokenization, previous tagging, and it does a sentiment classification. Now, let's say if the sentiment is positive, this is assumed that the classification based on the review content, but in practice, you would train a machine learning model on the labeled data to perform the classification. Now, there are certain other scenarios also where you do more complex text classification. You would train a model using machine learning techniques and also feature extractions like TF-IDF that we discussed, or word embedding. So this was a bit about SpaCy, guys. It is an advanced library that provides fast, efficient, and easy to use tools for various tasks. Now, we also did named entity recognition. So we learned that how SpaCy identifies entities such as organization, locations, and dates in text. And we also saw POS tagging and dependency using SpaCy. We explored how SpaCy assigns grammatical tags to words and analyzes syntactic dependencies between them. Then we also had something called as text classification, where we have used simple example of sentiment analysis, and also text classification tasks, which can be expanded to more complex scenarios using SpaCy's pipeline and custom models. So these techniques are building blocks of more advanced task processing, and it is useful in applications such as chatbot, content categorization, and sentiment analysis. Now, let us move to the next part where we are going to discuss a bit about word embeddings and language models. Okay, so word embeddings help machines understand words and language through models like RNN, LSTMs, and GRUs. And it helps machine process sentence. So I'll explain concepts in very simple terms and then provide you a very hands-on example for each one of them. First, let's discuss a bit about it. What exactly is word embedding? So word embeddings are a way to represent words as numbers. So we call them as vectors as they capture their meaning. So unlike traditional methods where each word is just represented by a 1 or a 0, as we have seen in one-hot encoding. So word embeddings create dense vectors that tell the computer the meaning of the word and how it's related to others. And if I talk about a question, why are they important? So guys, with word embeddings, like king and queen or dog and cat, so these strings will have numbers that are close to each other. So this helps computer understand relationship between words and their meaning. So for example, in word embedding, king and queen are close because they relate to royalty. And if you look at cats and dogs, they are relating to the animal side of this. Now let me show you by doing one hands-on. So we will use word2vec, which is a popular method for learning word embedding, and we'll see how it works. So the model that we will be using is 2vec. So first we'll install gensim, the library which will be helping us to do this respective method. So let us install. So pip install gensim. From gensim.models import word2vec. Okay, so this is done. Now let's move to the next part. So in the next part, what we need to do is we need sample sentences for training. So let's create this one variable. We call it as sentences, and let's say, for example, this could be, first one is dog barks. Then we have respective thing called dog. Then we can keep it as barks and keep it as loudly. And let's add one more part of it. Let's say man. Now we train the respective model all over here. So model equals to word2vec, and we can keep the sentences, and also we could keep the vector size, but I'll use the minimum count as one of the argument. So let me declare that. Let's keep it as 1. Now after this, what I'm going to do is I'm going to save the model. So what I could create one variable all over here, but we can use this model variable only. So we can just call model.save, and we can just pass it up as word2vec model. Now we could get the vector representation of the word dog. So how we are going to do it? So let's create one more variable all over here, and we'll call it as dog vector, and we'll use model.w and dog, and then we'll print the dog vector all over here. So this is a way of doing it, guys, if I'm using the word2vec library. And then I will check the similarity between dog and a cat. So let us create one more variable. We'll call it as similarity, and this is equals to, let's say, model.w.similarity. There'll be dog and cat, and then we print this respective similarity. Now let me explain you what exactly I am trying to do all over here. So the word2vec model, if I discuss about that, so we are using a small set of sentences where each word will be converted into a dense vector. So words that are similar like dog and cat, so they will have the kind of similarity, and by using this model, it will help us to give a brief idea regarding the same. So let's now run this respective code and see. So okay, we could see there is some issue happening. Okay, now let's try to run this, and you can see I'm getting a vector representation of each of the words that we had all over here, and this is giving us the respective similarity. So this is one of the most important thing. Now I'll also do one more task where what I'm going to do is I'm going to remove punctuation in Google Colab. So what I can do all over here, so let's say I have the sample text all over here. Let's import string first, and let's have the sample text all over here. Let's say we call it as hello and how are you. And after this, let's create one variable. We call it as text, no punctuation. And let's assign this to something called as join. So we'll use the empty dot and then dot join function. Okay. And in this, what I'm going to do is basically I'm going to use a list comprehension all over here. So char, so for char in text, if char not in string, so this is kind of done. And okay, we'll resolve this bit later. Right now, let's print it. So we can just call it as text, no punctuation. So you can see, guys, now the error is resolved and you can see there is no punctuation. So this was one of the very important tasks. But now let us explore some other important concepts. Now, guys, we will be using BERT model to do the pre-trained embedding. So BERT is a very amazing model which was developed by Google to extract word embeddings, to basically extract word embeddings. And if you are doing the text processing task and there are some more complexities to it, I will suggest you using this respective thing. Now, first of all, what I need to do is let's install Transformers. So pip install Transformers. Now, what I'm going to do is I'm going to extract the BERT embeddings. So for that, I will be needing BERT tokenizer and BERT model. So we can type from Transformers and let's say import a BERT tokenizer, and this is BERT model. Then what I'm going to do is next thing, I'm going to load pre-trained BERT model and its tokenizer. So let us declare one variable and we will call it as tokenizer. So let's say this is equals to BERT and dot from, and let's close this up. Okay. So what I can do all over here is, I think so something is missed. Let's correct it. So let's from pre-trained and then we can use it all over here. I can see the error is resolved. Now let's move to the next part. Let's say we have this respective sample text, and in the sample text, let's say I say I love machine learning. Okay. And let's say first let's take the given input all over here. So our next task would be tokenizing the respective text. So what I'm going to do all over here is first of all let's take the inputs. This is one variable, and let's say this is equals to tokenize, and we pass something called as text all over here, and we'll be returning tensors. So return tensors, repeat, and then we are going to return tensors. So this becomes pt all over here. Now after this, what I'm going to do is I'm going to get the BERT embeddings. So let's create another variable all over here, call it outputs, and let's say this is equals to model. Here we can pass the respective inputs. Okay, and all over here, what next we could do is we could also create one more variable. We could call it as embeddings, and let's say this is equals to outputs dot last hidden state. Okay, and after this, what I'm going to do is I'm going to use a print statement all over here. So print and BERT embeddings for each token, and after this we can pass this respective variable and we can call it as embeddings, which we have declared all over here. So let's pass it. Now after this, what we need to do is we need to run the respective code. Let me explain you what exactly I'm doing all over here first. See, I have declared one variable tokenizer, which is converting the input text into token of words, and which is understood by this model BERT all over here. Then we have something all over here, which is outputs.last hidden state. Okay. Now this gives us the embeddings for each token in the input text, and these embeddings are context dependent, meaning they depend on the surrounding words. And after that, guys, what I'm basically trying to do is I'm trying to print these respective thing. Now let me run it. Okay, and it's executing. Let's wait for a couple of time. So you can see I'm using basically Hugging Face library to perform this respective task. and it has started downloading all those things. It has loading the weight, and you can see the BERT embedding has given, and all these tensor values we have got, so which shows the exact relationship between the words, and it's mostly numerical, so you need to understand the current relationship all over here. Now, let me also tell you a bit about the language models, for example, like RNN, LSTM, or group language models. And language models are basically used to predict the next word in a sequence or to understand the context-aware sentence. For example, guys, most of the time when I try to write code all over here in Colab, and you will see it is using Gemini model, and it auto-suggests the respective thing. So language models are used to predict the next word, and they're very crucial for text generation and speech recognition, machine translation, and more. Now, there are a couple of models that we can discuss about. First of all, we have RNN, which is standing for Recurrent Neural Network. So RNNs are actually designed to handle sequential data, such as sentences, and they process the input one word at a time while keeping the track of previous word in the sequence. Now, what RNN is that RNN have a difficulty with long sequences because they tend to forget earlier words, and this is also called as the vanishing gradient problem. Now, next up we have is LSTM, which is long short-term memory basically. Okay, let me write it for you. And these are the same technique which Colab is incorporating Gemini, and we can call it up here recurrent neural network. Now, what is LSTM? So LSTM are a type of RNN that remember long-term dependencies very much better. They use special units called gates to decide which information to keep and which to forget. Now, the advantage of using LSTMs are that they are better at learning long-term relationships in the sequential data. Similarly, we have something called as gated recurrent unit. So what are GRUs? GRUs are very similar to LSTMs, but with simpler structure. They have fewer gates, which makes them faster to train while handling long-term dependencies effectively. Now we'll do one hands-on, guys, where I'm going to build a LSTM model for our text generation. So let's start by creating a LSTM model by predicting the next word in a simple sequence. So first of all, what libraries we'll be using is we'll be using Keras all over here. So let us install Keras first. So let's type pip install Keras. Okay. Now after that, guys, what we'll be doing is we will get the respective thing going. Now we'll also import a NumPy, okay? And next thing what we need to do is from Keras dot model, and I'm going to import sequential. Okay, let's make this as capital. Okay, fine. Then we need to also import layers. So we'll use the same thing from Keras dot layers, and we can call it as import LSTM dense all over here. Now, next thing, what I'm going to do is I'm going to also import all over here, and let's say this is Keras, okay, and we are going to import the pre-processing sequence also. So this is pre-processing dot sequence, and we'll be importing pad sequences all over here. Now, after this, let's have the sample text data. Let's create. It's called data. And let's say I love, let's say machine learning, and we can call next statement as machine learning is amazing. Now, next thing, we will get some simpler integer in counting of words. So let's create one more variable, and what we are going to do all over here is, so let's say this is the word, and to int, and all over here, let's call it as word, and this equals to I plus 1, okay, and let's say for I in repeat, and let's say we have something called it as all over here. So there's one mistake. Let's correct the parenthesis first. For word in enumerate, then we could use a set function, and in the set function, what I could type is all over here. I'm going to use the same join function which we used in the strings, and we can split the data. And what I'm going to do is I'm going to pass a function, repeat. I'm basically going to pass the data all over here, which is this variable, and then split it up. And then initialize the word I and do the list comprehension and iterate over this respective sequence. Now, guys, what next we need to do is let's create another variable X, and let's call it as pad sequences. And let's call it as sequences. And this padding equals to post, and Y, X and Y, these are the two variables that we'll be handling. So the port sequences, repeat. So guys, if I could see the pad sequence, which I have added all over here, I'm using the same thing. And the padding is of type post all over here. And let's call this respective thing. So model.sequential, this is LSTM model. So I'll just write it all over here. Okay. So now what I can do all over here is I could add the respective thing. So model.add, and let's call the LSTM. So let's say its first argument is 50, input shape. I've added x.shape1, x.shape2. So these are all the respective thing that I'm trying to do with the help of the LSTM model. And let's keep the parameter 1 all over here for this. Okay. And after this, what I can do is I could compile and add the optimizer, which is Adam, and also add the loss also. So these are the two variables that I'll be using, and this is a mean squared error. And next thing what I'll do is I'll reshape X to fit the respective LSTM input. So for the same purpose, what I will do is all over here, let's create a variable X. Okay, X is already there, so let's create this, or let's keep it as small one only, and let's make it as a big one. So X equals to, let's say, np dot, we'll use a numpy library to do that. So np dot expand, and you can call it as dims, and keep it access as -1 all over here. Then the next thing what I'm going to do is I'm going to train the respective model. And for training the model, what I'm going to do is I'm going to use the same thing, model.fit xy, and put epochs as let's say all over here. We can keep as a epochs value as 10, not that much, and we'll also pass the numpy array. So let's keep epochs as 10, and also we'll pass this variable x first. And next thing what I'm going to do is I'm going to pass this respective thing, np.array, and this goes with 1, 1, and 1. And after this, what we'll be doing is, let's say we have already passed epoch, so we can just close it up. And finally, what I'm going to do is I'm going to display model summary all over here. So let's call as print model summary, and we'll call this respective function. Now guys, what exactly we have done all over here? So we have used an LSTM layer to process the sequential data. And you'll also find there is a dense layer, which is output layer, that is making the predictions. And the most important part are the pad sequences that we have used. So which is basically ensuring all the input sequences are of the same length. So let us run this first. Let us see what is the respective output. And you can see it is calculating the loss function all over here. So epoch 10, epoch 9, and this is the given output that we are getting. What is the layer type, LSTM, what is the output and its respective shape, similarly the dense layer, and it's also giving us total number of parameters, what are the trainable parameters, non-trainable parameters, and optimizer. So this is how we used language models like all over here. So in this given thing, we have explored word embeddings like word-to-vec all over here, and we have used repeat, and where we actually represented word as vectors. And basically in the entire hands-on thing, we were trying to actually understand or capture the meaning and relationship of the words. So I have worked with repeat, and we have also worked with pre-trained embeddings like BERT, which can fine-tune for all these advanced text processing tasks. We have also learned a bit about RNN, LSTM, and grooves, which are used in language models to handle sequential data and capture the dependencies in text. So this was a bit about it. And now practice, guys, a bit more. I know it's kind of a bit complex at the first go, but these are some of the advanced concepts all over here. So guys, that's all for today's video. I hope so you would have enjoyed our today's course. And if you have any doubts, you can mention your doubts in the comment section below. And if you like these kind of videos, guys, I request you that do not forget to hit the subscribe button and click the notification bell icon so that you don't miss out any update from our end. Thank you guys for watching this video.